yourself, is this geometric, right? That should be the first thing. And the answer is no, because of the where? Okay, so because of the n factorial, right? So again, this n factorial, if I started writing out terms, there's not going to be a common multiplier to get from one to the next. Okay? So again, it's not going to be geometric. All right, so then it really becomes, I mean, from a what do I do idea, ratio test, right? And it becomes, there's some other things that, again, you could think about. Hey, is this series comparable to another one or something like that? But honestly, I would just, I mean, this is myself included, I just go right into the ratio test then. Okay? In reality, you can do the ratio test every single time the question asks you for interval or radius of convergence. Okay? The difference is if it was geometric, right, you wouldn't have to test the endpoints, right? Because geometrics only converge when the absolute value of r is less than 1, right? There is no inconclusive when it equals 1, like the ratio test is. So literally the only, I mean, benefit other than big picture idea that you can recognize something as geometric, and therefore you can find the sum of the series, right, with the series with sum to, which would be important, right, and you might get questions like that. Okay, you truly can, anytime a question asks you for the interval and radius of convergence, or either one of those, or both of them, or whatever, you can use the ratio test pretty much every single time, right? So I mean, it's something you can just do. Again, and ask you for the interval, you'd have to test the endpoints. Hopefully, you'd find that they didn't work if it was geometric, right? But you just cost yourself, a couple of minutes testing your endpoints, right? Not that big of a deal, probably. Okay. All right. So ratio test says to find the limit as n goes to infinity of a sub n plus 1 over a sub n, right? So replacing every n with n plus 1 and then dividing it by the original, right? Again, what do your terms have to be?
Positive.
Got to be positive, right? So your terms got to be positive, right? Okay, which means we're going to absolute value it, right? Okay. The other thing, right? And that's the other big thing why I've asked you over and over again to write an alternating series, right, with a -1 to the n, right? Is then I can ignore that when I do tests like this. Really ignore it when I do almost every single test. With like one exception, because as I mentioned yesterday, right, pretty much every single test we're going to do, right, is based on positive terms, right? Testing for that absolute convergence initially, okay? So when you've got this alternating one, just kind of ignore that. That's not really a part of your a sub n, right? Just kind of ignore that, and that also makes it positive then, right? It gets rid of that, right? All right, so now we just need to find it, right? This has got to be a little bit careful on this one, so it's going to be the absolute value of x 2 times n plus 1, right? Plus 1 over n plus 1 factorial, and then times the reciprocal, so n factorial over x to the 2n plus 1. And the limit as n goes to infinity.
You need to absolute value of the x?
Yep. Okay. It was there. Alright, so we basically, I would say there's kind of just 3 basic things that we do in these cases. 3 basic things that we deal with. Reducing powers somehow, right? Reducing exponents, canceling some exponents, subtracting exponents out, or rewriting it to cancel. Okay? Handling polynomials over polynomials, right? Or n plus 1 over n yesterday, right? And kind of just recognizing what that does. And then really dealing with factorials.